Okay, and again, so welcome to Simon.
Great, thanks everyone for going. So today I'm going to be talking about the R package I've been developing called Shinyscholar. And the aim of this is to help people create reproducible Shiny apps in R. The package creates an empty application with a regular structure, and the key feature is that analyses conducted in the apps can be reproduced outside of the app. The aim of creating this is to make it easier for developers to follow best practices in software development, and also enable them to concentrate on creating the functionality of the app rather than working out how to link everything together. As we all know, R has got really great statistical methods, but there can often be a lot of barriers to uptake. In my particular work, we're interested in enabling access to people who might have technical knowledge, but not necessarily know how to code. So people like conservationists or health analysts or medics. And the first problem is that they need to know how to use R. Then they need to be able to comprehend the documentation. And then often analyses would require access to some specific data, or that data needs to be formatted in specific ways. And all of these things make life potentially difficult for people who want to access the methods. Shiny apps really help in this. They enable communication between a web browser and a server running R. And so anyone can therefore access the R code. So using this really simple example, we've got a box where we can enter a number. It's then passed to the server, and the server returns the value multiplied by 10. And the ease of development has made Shiny apps increasingly popular in academia. So this is looking at Web of Science for the number of papers that have been published about Shiny apps. And the ease of use, the ease of development has made them very popular. But if we look at those apps, a lot of them don't necessarily follow best practices, either in scholarship or in software development. So, for example, they don't necessarily say which packages are used in the app, so users wouldn't be aware. They generally don't contain any instructions on how to use them inside the app, and events aren't logged. And almost never are they reproducible outside of the app. And then also looking at the source code, whilst they typically contain some functions, most are not organized into modules, some are packaged, and tests were almost entirely absent. So one app which bucks this trend is Wallace. Wallace is an app for modeling species distributions. It's been in development since about 2014. And it had a lot of features that we wanted to use in another app. So, for example, it contains guidance on how to use it in the app. There's an event logger, and also the sort of key feature that we wanted to use was the ability to reproduce any analysis conducted outside of the app. And then, from a code perspective, the code is organized into components. So these are the tabs across the top of the screen, and then modules, which are options at each step of that analysis. And so the idea of Shinyscholar was to take all the generic features from this app and produce a template for other people to use. So the first thing you need to do to develop a new app is create this data frame containing information on each of the modules. So continuing with a really simple example here, which is one module. The component and module names are used to create various functions in the app. And then the long names are used to create some of the user interface. And then for each of the modules, we've got options as to whether they interact with the map, produce results, need to be reproduced, save, whether they have a download, and finally, whether the module runs asynchronously, so the function can run in the background, which so if it's a long-running task like fitting a model, the app can stay responsive whilst that's running. So the modules data frames then pass to the main template, the main function of the app, create template. So we say where we want to create this app. the name of it, in this case demo, and then we say whether we want to include the app to include a map, a table, or have the source code available inside the app. Then there's finally then there's also common objects. So this is just data that's shared between modules. In this case, we've just got one, which is the result. And then this, if we run this, we'll have a new package installed called demo, and we can run the app with demo run demo. So this is what we get to start with. This is very much the sort of blank slate, but gives a lot of common infrastructure there ready to build upon. And so, in terms of the reproducibility, the way this works is that each of the modules calls a synonymous function. So we'd first of all develop this function, transform multiply, and then in the module of the app, we'd use that function, store the result in common, and then crucially we store any of the inputs used in that function in a meta object, and then in a separate R Markdown document for the module. We then use that same function, which can be knitted with the same input that was used in the app. And also created a function called metadata, which takes care of a lot of this boring code. As you can see, there's a lot of repetition and sort of duplication of names and things. And this metadata function basically handles all of that. So there's some examples of what we've used this for. Disag app is an app for disaggregation regression. So this is a technique that can be used to produce high-resolution predictions from data that's aggregated into polygons. So in this case, malaria in Madagascar. And then I've also been working on refactoring an existing app called Meta Insight for network meta-analysis. So this is particularly of interest in terms of reproducibility for NICE. So any analyses conducted that are now running this should be more useful to the community. So if you'd like to learn more, install from CRAN. There's also an example app on Shiny Apps, and you can also run that if you install the package with dependencies equals true. There's a README on GitHub, it's an extensive guide to developing modules, and there's also a workshop for Ukraine that you can look at where I go through developing a module. So then finally, just thanks to Welcome for funding the Wallace developers for doing a lot of the hard work for me, especially Rob Anderson for his encouragement, and then finally Tim for his advice. So yeah, thank you all for listening.
Thank you very much, Simon. So again, if you want to ask any questions, please add them to Slido. Should be coming up in a moment. I just wanted to ask, so this is great because you're getting like this skeleton, reproducible, well-designed template. When I think about design, I often come from a user design perspective, which kind of clashes because you're coming functional first. Could you talk a bit more about that?
Do you mean in terms of like having the UI sort of fixed? Yeah, I guess that is a sort of definitely like a valid critique. So I mean, this is definitely not suitable for all Shiny apps. Like, you know, if you have a really simple Shiny app, the beauty of Shiny is it can do really simple things.
Yeah.
But if you're wanting to develop an app for a complicated workflow, this is kind of designed for that.
So you have a kind of use case that is designed for.
Yeah, which is for sort of multi-step analyses. So, and you know, it is still a template. So you know, if you're still free to edit it and do whatever you want to afterwards. And you might have seen from the examples I showed, there were definitely some tweaks depending on the application.
Thank you. How does Shinyscholar compare to Rhino with respect to how it structures apps?
Yeah, so So Rhino is a bit different, and my understanding at least is Rhino is more suited towards well, like dashboard design and commercial usage. So one of the sort of where there's because there's also Golem, which is a sort of similar principle, and those definitely sort of inspired me to make this. So yeah, there are other things other packages out there which create these sort of skeleton apps, but they weren't particularly geared towards academic use. So that was the sort of main advantage to that.
Now we've got, can you explain a bit about the design choice of an R package over something like a cookie cutter template?
So I guess it's mainly just distribution. So I did initially I just created it as something which I thought, you could just fork it and go about it, but then I thought, well, actually it makes sense to make it easier to use. So having a template, having a function which actually creates everything, rather than requiring a lot of manual work to go and recode it.
Do you have any intentions of like creating a suite of templates for slightly different workflows?
I guess it depends. Yeah, if people are interested. Yeah, I mean, yeah, that would definitely be potentially possible. I mean, because whilst I've shown for quite complicated apps, you could definitely adapt it to be for a simple app as well, but using the same principles.
After generating an app with Shinyscholar, will there be any dependencies on Shinyscholar?
No.
Well, thank you so much, Simon.
Thanks.
Yeah.